All right, so let's look at a few more exercises, but first I want to talk real quickly about this key idea here. Uh, Wait, that's not a key. There, that's the key. This is an important idea. So, when you're not sure whether the solution should be one direction or the other, like with these previous examples, it's a good idea to plug in some numbers. And you could just plug in one number as long as you're pretty confident you're doing the arithmetic right. For example, here, if you're not sure if it should be less than -2 or x is greater than -2, try plugging in something less than -2, like -3, and check that it works. That's an idea I'd like you to keep using as we go through these exercises. So with that in mind, let's go over the answers to exercise 3. Let's just solve this equation. So this isn't a trick question or anything. We're just solving an equation the regular way. We just want to find out what x makes this true. So I'm going to add 12 to both sides to get an equivalent equation. 3x equals 12. Divide both sides by 3. You'll get x equals 4. So what does that look like on a number line? It's right here. Just a big dot. There's 4. That's the x you want. -1 over that way, but we don't need that. Okay, now what I wanted to emphasize here is that you can basically do the same steps to solve this inequality here. It works exactly the same way. So if you just add 12 to both sides, you'll get 3x is less than 12. Divide everything by 3. You'll get x is less than 4. So if you just imagine that this less than symbol was an equal sign, we found the value of x that makes 3x minus 12 equal to 4. 3x minus 12 equal to 0. It's x equals 4. Makes the original both sides of this equation equal. Now, if you're not sure, like, I added a number to both sides and then I divided both sides by 3. Does that mean I should change the direction of the inequality? Well, let's use this idea here to just check. Let's try x equals something less than 4, like maybe, I don't know, 2 is less than 4. So 3 times 2 minus 12, is that less than 0? That's going to be 6 minus 12 is -6 is less than 0. Yeah, so if that works, then 2 is on the side of 4 that you want. So yes, it should be x is less than 4. So quick on a number line. Here's going to be 0. We want things out on this side. Including 2, like we just checked. Okay, so that's those. Let's look at exercise 4. So in general, solving inequalities like this, the way to approach it is just like you solve an equation. Just do the same operations to both sides, which is going to give you an equivalent inequality, and you're going to get the number that makes them equal, and then it will tell you x is less than that or x is greater than that at the end. But there's a weird thing that happens. Let's look at this equation or inequality here. -2x is less than -6. If you wanted to get x on its own here, what you do is divide both sides by -2 to cancel out that multiplication, right? Right, Mr. Smith? Sorry, I couldn't hear you over the internet, but yeah, I hope you said that's right. But which of the following is the solution of negative 2x is less than 6? Is it x is less than 3 or x is greater than 3? Let's plug in a value from each possible solution into this to check, to see what happens. Okay, so if you think the solution is x is less than 3, let's try a number like x equals 2. You're gonna do negative 2 times 2. Is that less than negative 6? No, it is not. This is gonna give you negative 2 times 2 is negative 4. And negative 4 is not less than negative 6. And let's try a number greater than 3. Like, let's try x equals 4. Then let's gonna do negative 2 times 4. Is that less than negative 6? Negative 2 times 4 is negative 8. And that is less than negative 6. So that means 4 is a solution. So we want the side of 3 that contains 4. By that I mean x is greater than 3 is the solution here. So, okay, but notice that when you take this equation and you divide both sides by negative 2, what happened to that less than? Why isn't it still less than? Why does it get changed? Well, let's think about this. What if I was going to take this equation, negative 8 is less than negative 6. This true equation. Because remember, real quick on a number line, when you're on the left, that's always lesser. So here's negative 8 and negative 6. Negative 8 is to the left of negative 6. Now, what happens if you were to or divide both sides of this equation by negative 2? Which is what we're talking about doing here, dividing both sides by negative 2. Then that's going to give negative 8 divided by negative 2 is going to give you positive 4. And negative 6 divided by negative 2 is going to give you positive 3. Now, which one of those is greater? The 4 is, right? So this is why when you multiply something by a negative number, it like flips it across the number line. It flips it across 0. So 4 ends up over here. 3 is right here. And their order got changed. Now suddenly 3 is the lesser one. So that's sort of my visual illustration for why that happens. Now, does the same thing happen if you subtract 3 from both sides? That's what this exercise is about. So yeah, if you are going to solve x plus 3 is less than 5, you want to get rid of that negative 3 to get x by itself. You would subtract 3 from both sides, right? Right. But which of the following is the solution? Is it x is less than 2 or x is greater than 2? Well, let's try x, your favorite number less than 2. Let's try 0. Okay, so if you plug in x equals 0, you're going to get 0 plus 3 is less than 5, or 3 is less than 5. That is true. So that's probably the solution. Let's just check that x is greater than 2 is not the solution. I'm going to try, I don't know, 6. 6 plus 3, is that less than 5? No. All right, so this one here is the solution. So Subtracting by 2, that operation, if we're going to draw a picture of this, like let's say we have 3 and 5. Right here. There's the color I wanted. Okay, so there's 3 and 5 in the right order. If you were going to subtract 3 from both of these, it would move it to the left by 2. I guess the highlighting's not going to work here because we're going to now have the green on top of the blue here. So the point is they're still going to have the same order. I know, I'll just make another number line. So subtracting a number from both sides does not change the order that they're in. So you don't have to change a direction. So this is the same as it was before. But if you divide both sides by a negative number, this is going to get switched. And that's what this rule in the box says. If you multiply or divide both sides of an inequality by a negative number, you must change the direction of the inequality. Adding or subtracting does not change the direction. So let's use that to solve exercise 6 here. So what I would do first, just to make it a little simpler, is start by distributing the minus into here, subtracting each of these terms. It's going to give you 4 minus 3x minus 2 is greater or equal to 6 plus x. 4 minus 2 is 2. And I'll try to get all the x's on the left. So I'm going to subtract x from both sides. That will give you 2 minus 4x is greater or equal to 6. Subtract 2 from both sides. Gives you negative 4x is greater or equal to 4. And so far, all I've done to both sides is adding and subtracting here. So that does not change the direction. So far here, it's always the same way. But then I'm going to divide both sides by negative 4. Negative 4x divided by negative 4 cancels out to give you x. And that should now be greater or equal to negative 1. So that should be the solution. And remember the key idea from the top of this page. If you're not sure whether it should be less than or greater than, just plug in a number. So if you forget this rule, that's okay. Pick your favorite number less than negative 1. How about negative 5? So let's check. 4 minus 3 times negative 5 plus 2. And then is that greater or equal to 6 plus negative 5? Let's work this out over here. 3 times negative 5 is negative 15. Negative 15 plus 2 is negative 13. So this turns into 4 minus negative 13. Is that greater or equal to 6 minus 5, which is 1? So 4 minus negative 13 gives you 4 plus 13, which is 17, and that is definitely greater than 1. So yeah, we're on the right side. The less than is the right way to go here. All right, next we'll look at a couple more exercises.